Okay, lastly, now let's talk about Ambient Mesh and how it improves on what we do with sidecars while it's still yielding some of the same properties of the system. Okay, so we still have our fundamental two applications, A and B. And the first thing we should know is that they actually run on infrastructure called a node, at least in the Kubernetes case. And what we do in Ambient Mesh is instead of injecting proxies into the applications A and B, we run a daemon on the node that we call ztunnel. And it has the ability to capture the traffic coming into and out of these applications and to proxy it. Now, ztunnel differs from Envoy in a few kind of important ways. ztunnel does no L7 things whatsoever. All it does is L3, L4, MTLS, and authentication and authorization at that layer. So one of the properties that we get from ztunnel is I can go into a Kubernetes cluster today, I can install ztunnel in every node, and then I can flip a flag without restarting any application, and then all of the traffic in my cluster is now MTLS. Right, so we get this ability to go from 0 to MTLS with effectively no operational burden other than the install. And that, for many people, is actually what they want out of the solution, right? If my job is to go and make sure that I have FIPS compliant secure communication for all of the workloads in my ecosystem, then just doing this alone is sufficient to get you where you need to be, right? And that's a huge part of the value proposition of Service Mesh because I've hit the secure part. In Glue Mesh, we offer some additional capabilities in ztunnel to extract L7 telemetry. ztunnel will also report its telemetry to a system like OTel, and so we get that telemetry for free with no cost or churn to the applications. So we get this basic property of zero application churn. And since ztunnel runs at the node level, the applications never have to restart to be brought into the mesh, taken out of the mesh, and if the ztunnel needs to be upgraded, the applications also still don't have to churn. There's a full decoupling between the infrastructure responsibilities of the application team and the infrastructure team, right? As far as the application team is concerned, this is magical infrastructure. They never even know anything about it. And so the infrastructure team can just run rollouts, upgrades on the mesh, and never have to talk to the application teams. And so that makes the system much more operable, right? It means the velocity of maintaining, upgrading the system, and bringing new capabilities into the infrastructure is much better. ztunnel is also super optimized for this use case. So in general, for the L3, L4 case and doing MTLS, it is generally much faster. And we've got some good blogs out there showing the performance characteristics of ztunnel versus other secure networking solutions like WireGuard or IPsec for the same use case. And ztunnel generally outperforms these solutions. So that's the first major thing that we do in Ambient Mesh is bringing a layered L3, L4 security capability into the system and decoupling it from the application team and basically making it invisible to them, which is why we call the solution ambient. The other thing that it's designed to do, so let's say we have another node. Sorry, I'm terrible at diagramming. And this can be anywhere, right, in a hybrid environment. ztunnel, just like we do with the sidecar mode, can facilitate communication into the application regardless of environment, right? And we have capability to bridge networks across large distances and across environments to enable the connectivity. But the last thing that this does, right, is because this is all in the network and this is L3, L4, but we still want to bring L7 capabilities into the system, is we can inject into these network flows a pattern that we call a waypoint, which is just another form of gateway into the network path between specific applications and services in the network. And this is where all the L7 capability lies. Waypoints are configured Envoy proxies that sit in front of services. So C would have a waypoint and A would say, I'm going to talk to C. And the system is smart enough to say, well, A is trying to talk to C. C has a waypoint. I will make all the traffic go through this. And it will implement all the policy that C wants. Whether it's an access control policy at L7 saying you can call this HTTP operation, but not that one. Or whether you want to perform some routing or load balancing capability. What's important here is compared to the sidecar model, right? This is an Envoy proxy just like we use in the sidecar model, but this only has to scale to the amount of traffic in this particular network flow, right? As opposed to, let's say there were thousands of instances of C, but they were not serving an awful lot of traffic. I might need a very small number of these Waypoint proxies to sit in front of them. ztunnels are effectively free. They kind of just sit in the background noise of the infrastructure. So it's usually the waypoints that add some incremental cost, but because they're scaled to traffic, then not scaled to the unit of application, it's generally much more resource efficient. And so what we generally see is you need far fewer waypoints than generally you have numbers of instances of applications in your network. Very often one single waypoint can easily handle all the traffic into many, many replicas of a given application. That decoupling of the application deployment unit from the L7 policy and the kind of compute and storage memory requirements to implement it make the system much more efficient. And generally what we see is when we compare a typical deployment with a sidecar model versus the deployment with the ambient model for the equivalent use case, the ambient model is close to an order of magnitude cheaper. All right, so we see a much cheaper solution. And we have some kind of estimate tools that if you're already using sidecars in production, you can go and take your configuration, plug it into this tool that we make available on ambient-mesh.io to compare how much you're going to save by using the ambient solution versus the sidecar model for the same use case. And pretty much everybody has found it to be vastly cheaper to do so. This composability, by the way, also allows for a lot of flexibility in how we deliver capability. So we use Envoy today, and we build into Istio a control plane for that. But we can also use Glue Gateway instead of this in our own product. And all of the additional L7 capabilities and policy controls that we built for the enterprise use case and for the API management use case can now be used in this scenario as well. And the same goes true for the AI gateway products and the agent waypoint, agent gateway solutions. They can also be plugged into the network topology the same way, right? So by putting this L7 capability in the network, we've enabled a kind of composability in the system that allows for a rapid delivery and evolution of capability in the network. That would not be true in the sidecar case where it would have to be rolled out into every single application all the time, right? So we have a much faster evolution. And so those are the general large advantages, right? We have a vast improvement in operations because applications don't need to deal with the mesh operations anymore and vice versa. We get a layered system, so we can go from 0 to MTLS in a compliant solution without having to absorb all the other features of a service mesh, which means you can get to a very useful state very quickly. It's much cheaper, right, in terms of infrastructure and resource costs. And because of this pluggability, we can add new capabilities into the network to meet advanced use cases that we just couldn't do with the sidecar model because it was just really hard to perform upgrades and maintenance into the sidecar model. And so these are the primary advantages of the ambient mesh model versus the sidecar model, and what we think it really is the future of service mesh. Visit ambientmesh.io to get started.